Hey there, Advanced Math. I'm going to continue with equations with two variables today. Actually, you might want to, we're going to do tables today. Part 2 is tables. You actually might, we can probably use the same page 2 days in a row if you want to do part 2 tables and part 3 graphs. You can do that. So go ahead and label this like this for the next 2 days. We'll do two we do's. So make sure you've got room to do 2. You'll probably need a whole page for each one. The graphs, especially when we get there, those get pretty big. So unpause when you're ready. Close your notebook. Think with me. Okay, so this was a question we dealt with the other day, right? Isaac is 3 years older than his brother Matthew. Write an equation that models their ages and find some possible solutions. So last time we did this, we said, okay, well, there's 2 variables. There's 2 things I don't know. I don't know Isaac's age, and I don't know Matthew's age. All I know is that Matthew's age, Isaac is older, right? So Matthew's age plus 3 equals Isaac's age. It's as far as I really can tell. And when there's 2 variables, there's lots of solutions. So I can't look at this and say, oh, I know the answer to this. Because there's lots of possible solutions, and we wrote them like this. We wrote them like if Matthew is 3, then Isaac is 6. Or if Matthew is 8, then Isaac is 11. And stuff like that. So we're going to do this same idea today. We're going to write the equation, and we're going to do this kind of, well, if this, then this kind of thing. But instead of writing it out like this, the way you usually see a mathematician do it is in a table. So over here I'm going to draw a table. And instead of just writing sentences like this, what they will do is kind of say, they'll make a table, Matthew's age, Isaac's age. And the only difference really with a table is, other than missing the words, is I kind of go in a more systematic order here. So rather than just randomly picking ages for Matthew, I will probably do it more like this. I'll probably say, well, I'll probably just start from, say, 1, or even from 0. If Matthew was just born, Isaac is 3. If Matthew is 1, Isaac is 4. If Matthew is 2, Isaac is 5. If Matthew is 3. So we kind of go in a deliberate order rather than just randomly picking them when we use a table. And you'll kind of see why tomorrow. You don't have to. It's totally fine to then at some point have a break in your table and say, and if Matthew is 10, Isaac is 13. That's okay too. But usually you kind of go in an order, and you'll see why tomorrow when we do the graph. All right, let's do another one. So this was our second one last time. It says Johnny earns $7.75 per hour that he works as a lifeguard over the summer. Write an equation that models the amount of money Johnny makes based on how many hours he works. And we found 3 possible solutions last time. So let's rewrite my equation first, because I need that to start with. So I don't know how much money he makes, and I don't know how much hours he works. But what I do know is if I take $7.75 and multiply that by how many hours he works, that's going to give me how much money he makes. 775 times H equals total money. And so last time we did the if 1 hour, then this much money. If 2 hours, then this much money. If 3 hours, then this much money. So today I just want to write the same info in a table. Hours and money. And you'll notice I picked, this is kind of the one that we can adjust. Like this is the one we would pick, or we would want to know first how many hours. That leads to how much money. I usually put that one on the left. The one that's kind of has something happening to it, and the one I feel like I have more control over. So I guess one possibility is that he works 0 hours and earns $0. 0 times 775. He could also work 1 hour and make money would be $7.75. If H is 2, then M is, what did I say last time? 7 times 2 is 14. 75 cents times 2 is $1.50, so 15.50. If he works 3 hours, then he makes another 775. So that would be 22 if I add the 7, 22.50, 23, 25. And I just work my way up my table like that. Again, I may want to jump up and do one, like an easy one would be 10. If he works 10 hours, the decimal would move one spot. He would make 77.50. But so I'm just going to list my same info that we did the other day. Just instead of sentences, I'm kind of like if this, then this. I'm writing it just in a table. Excuse me. All right, open your math notebook. Let's do our other two together. So here was the first one we did together last time. If you want to pause and write the situation down again, let me show you how to set your page up. It's kind of a big situation. Leave me a little room today for the table. They don't take a whole lot of space up. Maybe do like this. Leave yourself a little room for the equation, a little room for the table, and then a big room tomorrow for the graph. Why don't you do that? So if you need to pause and write this down, go ahead. So 4th graders at a certain school are required to read 10 minutes more per night than 3rd graders. Write an equation that models how many minutes the 3rd graders and the 4th graders read. Find at least 3 solutions. And you don't necessarily have to write that if you want to save yourself some time. If you already did, don't worry about it. So first thing to do is write the equation. So I have 2 unknowns, 3rd grade and 4th grade. I do not know how long 3rd graders read at this school each night. I do not know how long 4th graders read each night at this school. And I'm going to set it up like this. So let's see. 4th graders read more. So I know that if I take the 3rd graders' time, add 10 minutes to it, that's going to give me the 4th graders' time. So that's my equation. And there's not one solution to this because there's 2 variables. There's many. And I'm going to show those solutions in a table. You can write solutions. So again, I usually put the one that's kind of by itself, like the one that the other one determines. So like here, I kind of feel like, well, I'm going to pick these to figure out these. That's kind of how I'm going to do it. So that one usually goes on the left, and the one that's sort of more like an answer, the one that you figure out after you know this one, that one usually goes on the right. And here we go. So in a table, we talked yesterday about reasonable solutions to this. I'm going to start by listing some not all that reasonable solutions, just because that's how the tables usually kind of work. So I'd probably start, there's a possibility 3rd graders just don't have to read it all at this school, no minutes. And if they read no minutes, 4th grade would read 10 minutes. If 3rd grade reads 1 minute a night, which I know is silly and not likely, 4th grade would mean 11. 2 minutes a night would be 12. And so now maybe I want to skip to some more reasonable solutions. Those aren't great. Maybe I'll skip down and say 10. If 3rd graders read 10 minutes, that means 4th graders read 20 minutes. And maybe one more. If 3rd graders read 15, 4th graders read 25. And so on. I'm not saying that's all the possible solutions. I'm just listing some. These show me the same information I figured out yesterday. It just shows me it in a different way. Okay? One more. You're going to set your page up the same way. Here. Brookwood runner trains by running 1/4 mile laps around the Brookwood track. Write an equation that models the number of miles the runner does based on the number of laps around the track that she runs. You cannot write this if you haven't yet. And we're going to set your page up again like this. We're going to write your equation. I need a little room for the table. And then I need a lot of room for the graph tomorrow. So if you want to pause and set up, go ahead. So again, two unknowns. I don't know the miles and I don't know the laps. I use T because L looks too much like a 1. So all I know is that 1/4 times however many laps she runs, because each lap is 1/4 of a mile. So one lap would be, well, we'll get to that. 1/4 times however many laps she runs. That's the total, excuse me, number of miles that she runs. Okay? And so I want to make my table. Again, I usually I'm going to put in laps to see how many miles. So the one that I'm going to like put in and test out, that usually goes on the left. And then the kind of the answer one goes on the right. So some days, not every day, but I'm sure some days she doesn't run. So that'd be no laps, would be no miles. She could run 1 lap, which would be 1/4 of a mile. She could run 2 laps, which would be 2/4 of a mile. She could run 3 laps, which would be 3/4 of a mile. And then maybe I'll skip to some longer ones, and I kind of talked about logical ones yesterday, right? Like kind of saying, well, if I do a multiple of 4, I'll have like a whole number of miles. So maybe I might pick 8. Say another possible solution is she runs 8 laps, which is 2 whole miles. And another possibility would be, say, 10, in which she would run another 2/4 of a mile, which is half. 10 would be 2.5 miles. And again, those aren't all the solutions. They're just some possible ones. All right. So hopefully that's not too much tougher than yesterday. We really did the same thing. We're just going to show it in a different way. And tomorrow we're going to do the same thing and show it in even a different way, so you totally understand how these 2 variable situations works. So that's all set. Once you've got these written down and you feel like you've got it, I'll see you tomorrow.